Good evening. Today is Thursday, November the 19th. Today in geometry, we looked at a concept called coordinate proofs. It's somewhat different than the normal statement of reason type proofs, which uses theorems and builds on theorems. So I'll show you here when I share the screen an example of a coordinate proof. So a coordinate proof, if we start with, in most cases, we start with a geometric figure. So I'll go ahead and draw the axis here. And we'll say, let's say we're going to have a triangle. Now, so a coordinate proof, we can take a given triangle here, and we can prove that if I connect the midpoints of any two sides, so let's say I'm going to connect the midpoint here, somewhere about right here, with the midpoint over here. And then if I do that connection, so I connect from here over to here, then what we can prove with coordinate geometry is that this mid-segment that I drew here is parallel to the opposite side. And we can also prove that it's equal to half the length. So what you have to do here, we have to set up our coordinates so that they have to be general. So for instance, this point right here, we know is the origin. So we'll let this be the 0, 0 point. And then we can come over here to this point and we can let it be some coordinates. So we'll say this is 2a and 0. Because we pick 2a instead of a because we're going to take half of it. So when we come up here to the top, we would have two other letters. Now notice I'm using letters instead of numbers. So 2b and some other letter 2c. Now, so what I want to prove, if this is, let's say this is a, this is b, and this is c up here. And I'll let this point here be D, and this point here be E. So what we want to do to start with, if these are the midpoints, remember the way we find coordinates for midpoints is we add the 2 points, we add 2b plus 0 here. So the x-coordinate is 2b plus 0, that's 2b. We divide by 2, so this coordinate here is b. We have 2c plus 0 for the y-coordinates is 2c, and we divide by 2, so we get c. Now over here at E, if we do the same thing, now notice we have 2b plus 2a divided by 2, so that's going to be a plus b. And then, of course, 2c plus 0 is 2c, and we divide by 2, and we get c. So now I have the coordinates of each one of these. I have the coordinates of DE, and I have the coordinates of AB. So you remember the slope, so I can come over here and talk about the slope of segment AB, and I'll put that here as a subscript. So this is the segment AB equals, and remember on the top we have y2 minus y1, which in both of these cases, that's 0 minus 0. And in the bottom we have x2 minus x1, so this is 2a. And of course, if we notice 0 minus 0 is 0. So the slope of that line is 0. Now, we come up here and do the slope of DE. We put our R's there, equals, okay, once again, we do our line. So on top we have C minus C. And on the bottom we have A plus B minus B. And on the top we get a 0. And on the bottom we get A. So the slope of DE is 0. And since the slope of AB is 0 and the slope of DE is 0, I've proven that if I connect those two midpoints, then the line connecting the midpoints is parallel to the opposite side. Now, just to show you that it doesn't have to be, I don't have to pick A, B, and DE. I could come down here to the midpoint of AB, and let's say we got a midpoint somewhere about right here. I could put a midpoint here and call this F. And then I could connect E and F like this. And I can show you that the same thing happens, right? So now if we look at this, so this is going to be 0. I mean, the y coordinate is going to be 0 here. But the x coordinate is half of 2a, which is a. So I got a here. Now, so if I do the slope from EF here, so let's look. So the slope of EF, I got the M of EF make this a little longer. Okay, equals. Okay, I got Y2, which would be C, minus Y1, which is 0 here, over X2, which is A plus B, plus B, minus X1, which is A. So I get a slope of C over B. Now, so I come over here. So this line is supposed to be parallel to AC. So I find the slope now of AC. So I've got M of AC. Okay, and then once again I do Y2. So I would let Y2 be 2C. So I've got 2C minus Y1, which is 0 here, over 2B minus 0. So that's X2 minus X1. And what I end up with is C over B. So what I've proven here, basically, if I take any triangle, regardless of its size or shape, and I connect the midpoints of two sides, then the segment connecting those two midpoints is parallel to the third side. Now, the interesting thing also here is that if you look, the length of the mid-segment, we call it here, is half of the opposite side, right? If I come across here at the bottom, see AB equals 2A minus 0, which is 2A. So I got 2A for AB, and DE is equal to A plus B, because my y is the same. So x2 minus x1, which is minus b, so that equals a. If I did the same thing for EF and AC, I would find that they are exactly the same. So what you'll see here, this is what coordinate geometry proofs are all about. And in some cases, as we go on through, you will find out that coordinate proofs are easier than the normal statement reason or two-column proofs or even the paragraph proofs. So if you look at your homework here, I'll go ahead and stop the share here. But if you look at your homework, you'll find out most of the problems only are requiring you to determine coordinates for given pictures so that you can set them up so that they can be solved using a coordinate geometry type proof. Now, if you look, tomorrow we're going to be doing our geometry plain and simple, so it's just a couple of worksheets. And then when we come back from Thanksgiving, the Monday will be a review. So Tuesday after Thanksgiving, which I believe is the 1st of December, that's when we will take our test on this chapter. So I will get with you sometime before that week and let you know what your test requirement is going to be for this chapter. So I hope you have a good Thanksgiving with your family and friends. Be careful with the coronavirus, and I'll be in touch with you on the 30th of November after Thanksgiving.